I was very fortunate just before Christmas to be able to go to Paris. I was there for the Conference of Parties to the United Nations Framework Convention on Climate Change. You can see why we use acronyms a lot in this field. Bottom line, we were there for 2 weeks with 195 nations from all around the world. Everybody was there. China was there. We're familiar with what China often looks like, choked by smog and pollution. They were there with a plan to shut down all the coal-fired power plants around Beijing in the next few years, with a plan to put in place an emissions trading scheme like Ontario and Quebec already have to reduce carbon emissions. India was there. India was there with a plan to replace all their streetlights with LEDs and to spearhead a 120-nation program to install large-scale solar around the world. And Canada was there. Canada was there and took the lead in saying, you know what, all the countries are here discussing a 2 degree Celsius target. What if we discussed a 1.5 degree Celsius target? The day that Canada threw that on the table, everybody just took a collective gasp and said, well, maybe we could. Every single country, 195 countries, agreed for the first time ever. When have we ever had every country in the world together and agreeing about something? But we all agreed. We agreed to reduce our carbon emissions, that from the perspective of a developing nation, or developed nation, I should say, and from the perspective of developing nations, of which there are many more in the world than us, to protect and support people who are already being threatened by a changing climate today. Why was everybody in Paris, though, and what led to this unprecedented agreement? To answer that question, we have to start with a look at our planet. This is often how we picture the world we live on, isn't it? As this pristine, untouched globe. And this is the way it was. It was until we started to multiply. Now we're at 7.3 billion people. I was looking at the number today on a website that scrolls through, updating as you watch. And so today, a more accurate way to look at our planet is not as this pristine, untouched daytime picture, but as the planet looks at night. This is a picture of the planet at night taken by NASA. Now, for the sticklers, I know it's nighttime here and it's daytime on the other side of the world. They took a composite image and they photoshopped it. I know someone was thinking that. When we look at a picture of the planet at night, we can see what a tremendous impact we are having. If you zoom in on southern Canada and the United States, we can see it even more clearly. You can see the GTA in this picture. You can see the 401 probably connecting us with Windsor and Detroit. You can see the impact that we're having on our planet. And especially you can see not just the lights of where we live, but something else up in North Dakota. Now, for people who are good at geography, this is not a major city up in North Dakota, is it? What we're looking at here is we're looking at the lights of thousands of flaring wells. All the fracking that's been going up there, you can see it. You can see it down in Texas where we live. Now, most of us are much more familiar with the visual impacts of climate change on our planet. We know what smog looks like, whether it's here in Toronto or in Beijing or down in Salt Lake City. We know what pollution looks like. We know what plastic in the ocean looks like. We know what algae clogging up our streams and rivers and lakes look like. We know what these things look like. And so this is where the concept, the theological concept of creation care came from. Starting in Genesis 1, where it talks about humans having been given responsibility, not just over this planet, but over every living thing on the planet. It's about more than just caring for creation today, though. 195 countries don't go to Paris to talk about air pollution. They go to Paris to talk about something that's even bigger than that, something that began with the Industrial Revolution. Now, the Industrial Revolution was a good thing. Many of us live much longer lives, much healthier lives, hopefully much more fulfilled lives because of all the amazing technological advances that were made. Not just in terms of our quality of life, but in terms of medicine, education, ability and freedom to do what we want to do with our lives. The Industrial Revolution had enormous benefits for us as humans, and it continues to benefit people today. But as with so many decisions that we make in life, they seem like the right decision at the time, and then a year or 10 or 300 down the road, we realize that there were some unintended consequences that went with it. The Industrial Revolution was founded on the use of coal, oil, and natural gas to power our industry, our transportation, our lights. When we burn that stuff, it produces carbon dioxide, and the amount of carbon that we're producing over time has been going up and up. Where does this stuff come from? Well, here in Canada, because we all care about where it comes from here in Canada, right? Here in Canada, about a quarter of it comes from the oil and gas industry. Almost a quarter comes from our transportation. And then there's contributions from heating and cooling our buildings, from keeping the lights on, from the natural resource industry like mining and smelting and timber, 10% from our food and our agriculture, and 7% from waste. Now, there's probably a few people here who saw a movie called Cowspiracy that purported to say that almost all of our emissions come from food, and sadly that's not true. If it would, giving up on the steak would solve the problem. But it's really hard to solve the problem when it comes from all these different aspects of our life. Why do these carbon emissions matter, though? These carbon emissions matter because I'm going to do something that I have never done before. I'm going to show a video and animation while I talk because it's so much more fun to actually see it while I'm talking. Okay? I hope this works. Nope, it didn't work. Let's try that again. No, it didn't work again. Don't you hate that? Come on. There's a little arrow. There we go. Okay. Now it's working. You can see that it's kind of moving. Why does carbon dioxide matter? It matters because our planet has this amazing natural blanket already made of carbon dioxide, methane, and other heat-trapping gases. When the sun shines, that sun's energy goes right through that blanket as if it were a window, and it heats up our planet. Our planet gives off heat energy, and that gets trapped by the blanket. That amazing natural blanket keeps our planet 33 degrees Celsius warmer than it would be otherwise. If it weren't for this blanket, our planet would be a frozen ball of ice and we wouldn't have this amazing life that we do. Well, so if this is natural, what's the problem? The problem is that when we burn all this stuff, we produce an extra blanket. A blanket that our planet never needed. It's kind of like if you're staying at your grandma's house and you have a perfect blanket and she sneaks in like my grandma always did and puts an extra blanket on you and you start to sweat. That's what's happening to our planet. We're wrapping an extra blanket around it, a blanket that our planet never needed. And that's why it's heating up. That worked. That's awesome. Yeah. This was a really cool video that some people did. They took a presentation I did, and they just took what I just said in the presentation, and they made it into this cartoon. You can watch it on Facebook if you want to follow up. So that's why this matters. Now, the next question you might say is, well, is that really happening? Is the planet really heating up? Because it's pretty cold outside now, right? We're not talking about weather. Weather is like a single tree in the forest. Weather is what happens in a certain place at a certain time. We're talking about climate. Climate is the forest. Climate is the long-term average of weather over at least 20 to 30 years. So if you listen to the news a lot, you'll hear people saying things like, oh, well, it hasn't warmed in the last 10, 11, 12, 13 years. And they say, here's global temperature. Look, I can take global temperature from, say 2001 to 2011, and I can just draw a line through it, and it's not going up. So where's global warming? What is climate? Climate change is the average temperature over 20 to 30 years. So when we look at the whole record, this is what we see. We see that some years may be warmer. Other years may be colder. Some months, like our December here, may be warmer. Some months, like our January here, may be colder. But long term, it goes up and up and up and up. Last year was the warmest year on record. This 2015, this past year, is going to surpass it, and 2016 might even pass it. This is happening around the world, and it's happening right here in Canada. This is showing our different seasons. We have our winter and our spring up top. We have summer and autumn on the bottom. We see that Canada is warming, especially most strongly in the winter and spring, and more towards the north and up west than it is down here where we live, but it's still warming. Why does this matter? Well, we're seeing this all around the world. Up in the Arctic, Native Americans and First Nations people are experiencing this firsthand. The ground on which they've built their infrastructure, their homes, their buildings, is now melting and crumbling into the ocean. They're losing the places where they live. Down in the Gulf, we're seeing that hurricanes that get all their energy from warm ocean water are getting stronger. We're not seeing more frequent hurricanes, but we are seeing stronger hurricanes as they suck up more energy from the warm oceans. In Australia a few years ago, they had a heat wave that was so severe that they had to add a new color to their temperature map. Do you see that light purple in the middle? It's 54 degrees. Yeah, and they kept it because they've had to use it again since then. And we're also seeing not just melting permafrost, not just stronger hurricanes, not just longer and stronger heat waves, we're also seeing more heavy rain and snow events. Because in a warming planet, more water evaporates, so it's sitting up there, and when a storm comes along, there's more water vapor for it to pick up and dump on us. If it's above freezing, it falls as rain. If it's below freezing, it falls as snow. We're not just seeing this here in Toronto. We're seeing this even where we live. This is a 6-lane freeway in the little town of Lubbock, Texas, where we live. Underwater when we got record rainfall a year and a half ago. If we look around the entire planet, we see 26,500 different lines of evidence showing us that the planet is warming. My birthday's in April, and my favorite flower is the tulip. So every year on my birthday, living in Etobicoke, I would hope and hope and hope that the tulips would be out in time for my birthday. A few years they were. Nowadays, by the time my birthday rolls around, the tulips have been out and gone. Because we're seeing these changes, like I said, some of them in our own backyards. Now, some may say, but why are you saying it's humans when we know that we've had natural cycles before, right? We know that there was a thing called the Ice Age. If you have kids, you've seen the movie 50 times. Not to mention number 2, number 3, and all the extra cartoons that they make. So we know that our planet has looked different in the past. How do we know that that isn't why it's warming today? Well, there's 2 main reasons why our planet has gone through warm and cold periods in the past. One is the sun. If the sun's giving us more energy, our planet gets warmer. If the sun's giving us less energy, our planet gets cooler. The second is those types of natural cycles I talked about. So let's look at the sun first. Here's the temperature of our Earth. The wiggly line is the year to year, and the thick curve is kind of the long-term average. If our Earth were warming because of the sun, does that mean we'd be getting more energy from the sun or less? This is an easy question. Less, right? So let's look at the sun. Well, over the early 1900s, energy from the sun was going up. It peaked in the 1970s, and since then, it's been going down. So if our temperature were being controlled by the sun right now, we'd be getting cooler, not warmer. What about the natural cycles that cause the ice ages? They're fascinating, coming from an astronomy background. I love how we can understand from basic geometry the fact that over time, our Earth's orbit gets more circular and then more elliptical. Also, the tilt of the Earth's axis precesses over time, and that changes the way that sunlight falls on the Earth. We know that this is what drives the ice ages and the warm periods like we're in today. But we also know that the warm period that we are in today peaked 8,000 years ago. And if we look at the Earth's temperature over the last 6,000 years, what was it doing? It was gradually cooling. And in fact, you can calculate from geometry that the next thing on our geologic time horizon, Geologists, as you know, operate in thousands and hundreds of thousands of years. On our geologic time frame, the next thing coming is another ice age. Not today, not tomorrow, not next year, but long term. At least I should say it was another ice age until when? Until the Industrial Revolution. Until carbon dioxide, which had been relatively stable, all of a sudden peaked. So according to the sun and according to natural cycles, we should be getting cooler right now, and we're not. And what's amazing is that the science that I have just showed you, we have known for a really long time. These are the scientists who discovered everything I just talked about. These are their real pictures. These are not like made-up old-timey pictures of modern scientists. Fourier, back in the early 1800s, was the first person to discover this amazing natural blanket that our planet has. In the early 1900s, we knew about that. By the mid-1900s, with the second guy whose name is Tyndale spelt a different way, an Irish chemist called Tyndale was the first person to figure out that coal mining was adding an extra blanket to our planet. That cute little video, that cute little cartoon video, we knew that stuff in the mid-1800s. Isn't that crazy? The guy in the middle was the first person to calculate, using physics by hand, how much the planet would warm if we doubled or tripled the amount of carbon dioxide in the atmosphere. He thought it would take 1,000 years or more. Today we're on track to do it within most of our lifetimes. The guy, literally, the guy's name is Guy, number 4, he's the first person, a British engineer, to measure how the planet was already warming in the 1930s in response to the choices that we made as humans. And then the last guy was the one who set up the observatory on Mauna Loa. If you've ever been to Hawaii, on top of Mauna Loa, there's an observatory for carbon dioxide, and he's the one who set it up. So we've known about this for a very long time, and that's why we are so certain not just that humans are responsible for our warming today, but that our choices matter. If we continue on our current pathway, we are going to end up in a very different future than if we transition to a clean energy economy fast. So that's where the United Nations Framework Convention on Climate Change comes in. Now, again, what many people don't realize is this Framework Convention, which everybody was in Paris to talk about and to agree on, it was signed in 1990. In 1990, almost every nation in the world, not quite 195, but a good chunk of them, signed this statement saying that we want to stabilize heat-trapping gases, carbon dioxide and methane, at a level that would prevent dangerous human interference with the climate system. We agreed to that 25 years ago. What have we been doing since then? We've been arguing over what's dangerous. How could we argue over what's dangerous for 25 years? It's because it's not a science question. You might say, well, what do you mean it's not a science question? Well, I have a question for you. How many cigarettes will give you lung cancer? The number is somewhere between 1 and, I don't know what, 100,000? I have no idea. For many of us, you might make the choice to say any of them are dangerous. Some people might say, oh, the occasional one's okay. Some people might say, oh, well, I just keep it to a pack a week. What's dangerous? That's not a science question. Science can inform that. And I'm going to show you a couple of examples of the work that my colleagues and I do to try to inform this choice. This first example looks at crop yields. So we looked at 5 of the most important crops in the world. We looked at maize, which is corn, soybeans, and rice. We looked at, as the world warms, so as the world warms by 1, 2, 3, or 4 degrees, what would happen to yields of those crops? We can't say what's dangerous, but we can say at 1 degree, 3 out of the 5 crops will see decreases of about 10% on average in their yield. Now, you'll still have good years and bad years, but on average they'll be down 10%, and 2 will be stable. By the time you get to 2 degrees, 2 will still be stable, but 3 of them will be seeing drops of about 20 to 25% in their yield. And again, this is with more people in the world. The work I do looks at heat waves, and so I made these maps showing that how much longer heat waves would be, how many more days heat waves would last as the world gets warmer by 1 or 2 or 3 degrees. This is what science can tell us. And this is the work that scientists did for Paris. And the last thing science can tell us is, if we decide what's dangerous, if we decide to aim for a 1 or a 1.5 or a 2 degree Celsius target, as we did in Paris, science can also tell us what our cumulative carbon emissions can be. So in other words, if we're going to go for 2 degrees, we know we've already produced 0.6 thousand gigatons. We've already produced more than half. This line here was from 5 years ago, so the line's gone up since then. We've already produced half of our budget. It's like we have a certain amount of money to eat for the month, and we've already eaten half of that food on a steak dinner the first day. That's what science can tell us. Science can also tell us where those emissions have come from. This is looking at, from 1900 to 2005, which nations have produced all the carbon. Now, looking at Canada, we might feel pretty good. But if we do this per person rather than for the whole country, we look pretty bad. So let's not do any of this yet. And then lastly, science can show us who is bearing the impacts of this. And if you look at this map, it's pretty much the opposite, isn't it? This is where the carbon's coming from, and these are the most vulnerable nations. But this is where the science stops. Because the science can't tell us what to do. As one of my favorite scientists, John Holdren, once said, he said, at this point, we have 3 choices. We can reduce our carbon emissions, we can prepare or adapt for a very different future, or, and this is not a sciencey word at all, we can suffer. We're going to do some of each. We can't pick which one. We're already doing all 3. But the question is just what the mix will be, because the more we reduce our emissions, the less we have to prepare for a very different future, and the less suffering there's going to be. So the science can give us facts and data and information, and we take all of what's in our head. We take that to Paris. We take that to the decisions that we make every day in our ordinary lives. But the choices we make are not just informed by information and facts, they're informed by what's in our hearts. And so that's why I'm so excited about this discussion we're having here tonight, and that's why we're having it here at Tyndale, because what is in our hearts is often informed by our faith. And for us as Christians, we have, in the Bible, we have a litmus test of understanding what is of our faith. And this, to me, is the most comforting thing, because so often when we hear people talk about climate change, there is, at least where I come from, there's a lot of anger, and there's a lot of fear. There's fear on both sides. There's fear that this could mean enormous suffering, that this could mean the end of the life as we know it. But there's also fear that if we take this seriously, if we say that climate change is real, that would mean the end of our comfortable lives. We might have to actually do something about this instead of ignoring it. Or it might mean that I couldn't be the person I am, that I would somehow lose my identity if I say that climate change is real and we have to act on it. So that's why this is so comforting to me. A verse from 2 Timothy tells us very clearly that the spirit of fear is not coming from God. What do we have as Christians to deal with this global issue of climate change? We're not to approach it from a spirit of fear, but with a spirit of power, the idea that we could get stuff done, of love for others, and a sound mind, which as a scientist I love. The idea that we can use our sound mind to make good decisions. We're also told, furthermore, to walk in love, to love others as Christ loved us. So what does this look like, practically speaking? Practically speaking, it looks like, first of all, recognizing that people today are already suffering the impacts of a changing climate. Whether they are being flooded, losing their homes and their possessions in Bangladesh, or in Texas. Whether they are suffering the impacts of worsening air quality, because not just is air quality caused by burning fossil fuels, but as it gets warmer, the chemical reactions that cause the ozone speed up. Whether we live in China or whether we live in Salt Lake City. So first of all, and the biggest thing I took away from Paris was, we have to recognize that this is already a real problem. People all around the world, our brothers and sisters, are already suffering the impacts of a changing climate. And to say to them that, oh, this isn't real, is an insult when they're experiencing it in their own lives and they come to Paris desperately saying, help. That's the first thing we need to do. The second thing we need to do is recognize that there's a different way of doing things. Yes, using fossil fuels have gotten us a long way with many benefits. This is a picture, though, from Texas. This is just about an hour away from where we live, where rusting oil rigs are being replaced by shiny white wind turbines. I had a chance to spend a day with a farmer once who had oil rigs on his property. He didn't have any wind turbines, but his neighbor had wind turbines right up to the border of the property. So after we'd spent about an hour together chatting and we'd eaten lunch and we'd established that I knew somebody who went to his church and he knew somebody who went to our church, then I felt like I could ask him. So I said, if you don't mind me asking, is there a reason why you don't have wind turbines? And I was expecting him to say something like, oh, that's just something for those green tree huggers, and I spit on that. He didn't. He said, yes, there is a reason. I said, well, what is it? He said, I've been on that list for 2 years. My neighbor signed up before me. I've been waiting for my wind turbines. Now, he's not a tree hugger at all. I mean, just to be clear, there are no trees to hug, first of all, in West Texas. So I said, well, why do you want wind turbines? And he said, well, because the check arrives in the mail. He said, I get exactly the same amount from wind turbines as I do from the oil rigs, but those oil guys are driving in and off my land all the time, messing up my fields and my roads. The wind turbine guys, they set it up and they control it from Florida. The cost of wind in Texas, which is setting records, by the way, for the most wind ever generated. If it's a windy day, we're getting up to 30% of the energy in Texas coming from wind. The price has gone negative some nights when people aren't using it, but it's windy. Negative. Wind companies are actually paying to put it on the grid. So the second thing we have to recognize is not only is that a changing climate is here, but that the solution is here, whether it's in Texas or whether it's in Africa. There is a new way of doing things that cuts air pollution, that weans us off our dependence on very old ways of getting energy that we've been using for hundreds of years. And it is the way forward into a better future, and that was what we were talking about in Paris. Now, some may still say, but fossil fuels got us where we are today. Shouldn't Africa, Southeast Asia, Latin America have that same advantage? If they had the fuels, yes, but it turns out they don't. Did you know that North America has 37% of the remaining fossil fuel resources? Europe has 20%, the Middle East has 20%, and the rest of the world has the rest. They don't have a lot of fossil resources in Africa. What they do are mostly in Nigeria. But they do have a ton of sun and a ton of wind. So if we really want to love people, loving people consists of, first of all, recognizing that they are suffering today, and second of all, recognizing that there is a huge potential for helping them in new and different ways. Not insisting that they sign up for the party line telephone, but rather recognizing that we have cell phones today. Not insisting that they sign up for the fossil fuels that they don't have, they would have to buy from other countries, but realizing that there's a different way to do things. And so that's why the spirit that I left Paris with, and the spirit I think that most people left with, was a spirit of hope, not fear. A spirit of hope that, yes, there is a better future. There is a way there. It's already on its way. And one of the biggest things for me was the fact that the faith community was there adding their voice. The World Evangelical Alliance, which represents 600 million of us around the world, were there. The head of the WEA, a man called Ephraim Tyndale, is from the Philippines, and he was on the official delegation of the Philippines to the COP meeting. He and many others were there lending our voice, saying, you know what, we have all the data, we have all the facts, we have all the science, but we need our hearts too. And what our hearts as Christians say is that not only do we have responsibility over this amazing planet that we live on, but we have a love for others, and we have a responsibility to share the love of God with others. And we can do that by walking with them in their suffering, but also by helping with the solutions. Thank you.